Welcome back. Well, you've all seen smart houses and lights being controlled on your phone and so on. I thought it'd be fun to have a go myself and do something, although not quite the same, something quite similar. Of course, when you do it yourself, it's going to cost a little bit more because you have to buy all the hardware, and you haven't got miniaturized, specialized bulbs and things and smart bulbs that you can buy. So for this, I'm just going to use an incandescent bulb and control its brightness over the output with a web page, basically. So I could use a mobile phone, and I can do it manually as well. I'm going to do it manually with a quadrature encoder as the control for the PWM. And for that, this is the program here. I'm just going to modify Rui Santos's program from the Random Nerd tutorials, and I basically just put in extra display information. I'll give you this software, and tells you about it's an I2C interface, not an SPI. So there's the pins for that, and I've got a interrupt to do the quadrature when I get quadrature pulses out of the thing, and there's the thing that Rui wrote. That's the actual web page, and I'll get round to that in a minute. And you've seen it before anyway. It's just a slider that goes from 0 to 255. The reason it goes to 255 is because we're just assuming it's 8-bit PWM. Of course, we could have 16-bit PWM if you wanted to, but it doesn't seem to be much point when we're only controlling a light. And I've restricted the output here of the quadrature encoder to be between 0 and 255. Because I've got two controls feeding into the one light, I've got the web server and I've got the manual one. I didn't know what to do with them, basically. I mean, I could have switched between them, but I just added them together, but prevented the overall output going greater than 255. So the PWM goes into the board. Now, what I actually use for this is this board here, which is 8 amp AC light dimmer module, works 50 or 60 hertz. And what it is it's a triac circuit. Triacs I thought were almost obsolete, but they're still going strong apparently. I mean, the reason I thought they were obsolete is because they're older than me, really. I thought everything was powered by power MOSFETs nowadays. But triacs is still going strong, and very small devices now. So this board here, it's got the low voltage side here and the high voltage side here, and you've got to be very careful here. You see the inputs as 2 neutrals and 2 lives, 1 live in and 1 live out. Make sure you get them the right way around. Don't just put this board down on the desk and just connect the wires up. I've seen people doing this. It's not a good idea. If you're not happy with mains voltages, or you're not getting any experience, I recommend you might want to leave this one alone and do a lower voltage version. So what I did was I put everything into a plastic box, and I mounted this thing with 4 nylon mounts and nylon screws. Everything is plastic, and I kept these wires from being pulled out. They're mains wires, and I used special connectors to stop that happening. Otherwise, you can give it a tug, and then you've got a live wire coming out, which I can show you in the demo. So this you can use on a whole range of micros, or Raspberry Pi, whatever. I'm using the ESP32. A little bit about triacs. Triacs are a silicon-controlled rectifier. Actually, the simpler version of the triac is the thyristor, where it does half-wave rectification. In other words, it doesn't give you the negative half, and it chops out a bit of the waveform here. You can see this bit here, so it doesn't conduct until a particular angle. It's called the firing angle, and then it rectifies, and then it doesn't conduct until there. So you can do an analysis of that, and you can find out when the the average voltage, that of course it's going to be less. It's a little bit like PWM in that you're varying the width of the the waveform that's coming out, but not quite. And it's not pulses, it is supposed to be an AC waveform. It will have a fundamental frequency if you do the analysis for it. People have probably done this lots of times. Funnily enough, the first thing I ever did when I was a student in first year was we were asked to analyse thyristor circuits. It was the first thing we ever did, and we had to work out what the average voltage was around the for a thyristor circuit for a particular angle using integration and so on. I don't think we did triacs. Well, we did do triacs, but I can't remember doing the calculations. So triacs are used to control the power to devices, like incandescent bulbs or inductive loads. When you've got inductive loads, you've got to be careful because they can give rise to spikes in the triacs. But snubbers of the device, just an RC network across it, is supposed to reduce this, although it does have side effects as well. This circuit, this board has got built-in snubbers, and although I haven't tested it on an inductive load, I've read some good things about it. Okay, so that's the board itself. I bought it originally from Amazon. It was actually more expensive and it never arrived. So I did get a refund. I don't know why it never arrived. They're usually very good. But it's been weeks and weeks afterwards and nothing's happened. So I reordered it from another company, and it's actually slightly cheaper from this company, $14.90. The program itself, I've just mentioned, it's just a variation on the Rui Santos one, where you've got a web server. You can control something over the web. The only so really what we're doing is we're just generating pulse width modulation, and the pulse width modulation goes into that board, and out of it comes it controls the controlled full wave rectification, basically, of the AC, which is connected to my incandescent lamp. I don't usually use incandescent lamps, I should say. I think in Europe they've banned them. You might be able to use them as heaters because they're very wasteful on energy. But in this particular case, I thought I'll play it safe and just use an incandescent just to demonstrate it, because it's not something I'm going to be using generally anyway. It's just an exercise. So that's the web server. You need to log it. It needs to log into your local Wi-Fi internal network. Of course, it needs your SSID and password, which I've not put up here. Of course, it's down as XXX somewhere, and then it'll tell you what the IP address. It prints that on the serial port, so you can do a view serial. And once you've got you've got that, you can look at the actual the web page and control the PWM over the web. So you could control it anywhere in the house. If you want to go outside the house, you're going to have some fancy external IP address in a server or something. I haven't investigated that bit yet. But that's it. So let's look at installing this board and get it up and running. As I say, safety is your number one priority here. So be very careful if you're doing this. If you're not happy with working with mains voltages, don't do it. Okay, simple as that. Pick something safer. Just want to quickly look at there's a circuit board here. Where is it? Oh yes, down here on the circuit diagram rather. That's the connectors that you use from the mains. So it's got two neutrals, live in and live out. So your line in goes in there. So that comes from the mains, and live out goes to your bulb. And the way I did it was I put a multi-way connector. I didn't want to start cutting wires and connecting to, so having slapshot sort of connections and things. So I butchered a multi-way connector and used it instead, and then I can just plug in my bulb in the normal way, which you'll see in a minute. So PWM, this is the low voltage side, which is totally isolated by using opto-isolators, so it's perfectly safe. PWM goes in to the other side, and you just got a supply voltage and ground. You've got an extra ground there as well. You can do this. I didn't do this, but this is a sort of analog way of doing it. So instead of putting PWM in there, you can actually just put DC in it apparently, and it takes that, which is quite neat. So you just can put a potentiometer across it. Forget about the ESP32 altogether, but then of course you won't be able to control it by the web. You just control it with a controller. Here's it being used from an Arduino, I think it is. Anyway, let's get on to the demonstration. Thank you very much. So here's the setup. I've got an ESP32 with a built-in web server, and I've got the IP address of that because the program gives me that when I run it on the serial port. But I've disconnected it from the computer for this demonstration, no particular reason. I just thought it'd be nice to have it stand alone. So I've got a 5-volt supply for that coming from a switching adapter from the 240-volt mains in this country. And I've got a little display. As you see, that's the organic LED display I used in the previous video. And the quad-digit encoder I've been using all along. This is an expensive one, but you don't have to have quite such an expensive one. You see it goes from 0 to 255. And the reason for that is because it's 8-bit PWM, I've defined it as, so it goes 0 to 255 with 8 bits, 2 to the power 8. Now this is the bit you need to be careful of. I can get that properly filmed. This is the board, the TRIAC board. The good thing about it is the high power and the low power part is separate. So the low power is here. That's over here. That's the input from the micro. All you need is PWM and the power supply really and the ground. And this is the dangerous bit where you don't want to be touching. It's the mains in and the mains out. They've got the mains out going to this adapter multi-way. I mean, I only need one, but the reason I picked that is this is just a standard thickness mains connector you get in the supermarket, and I put on glands onto it. Oh, you can just about see it. The computer's lit up, the camera's lit up, and you need to put it in a plastic box so you don't electrocute yourself, because although it may look, you don't need to do that. It just needs your elbow to hit it or something like that, just to pull a wire, and the thing will pull off and end up on your lap or something. So I don't recommend you do this unless you really know what you're doing. And up here, I mean, I could use it's come up a funny colour. For some reason it comes up blue, but it's actually white. This is my ESP server web page with a slider, and I can change that from 0 to 255. I'll just use the manual control to begin with, and as I change it, you might see the light getting brighter, and then it's dimming down, brighter, dimming down. And on the scope you'll see the pulse width modulation. That's maximum, so that's like 5 volts coming out, and then as you reduce it down, the mark to space ratio changes, so the DC level of that changes, and eventually we get down to something approaching 0, well, it disappears altogether. So I can leave that control alone, and I can go to the browser, and I don't know if you should be able to see it. As I change this would be done remotely, of course. It is remote anyway. As I change this, you see the light getting brighter, and that's it at maximum there. So I'm just using an incandescent bulb. I'm not sure at the moment whether you can use LED ones for this. I just avoided that anyway. This is not going to be a permanent fixture, so It's only a demonstration. And that's about it. So the things to look out for is beware the dangers here of the high voltage if you're going to be doing that, and make sure everything's insulated in some kind of housing with this plastic. It doesn't have to be this big, of course. And make sure that the lead has got something to stop it. So something to stop the lead when you pull it. Otherwise you could pull it out and then you've got a live lead coming straight from the mains, which isn't a good idea. I mean, there's probably even better ways to do it than I've done it, but for a brief demonstration, that's about all we need. So once again, the display was same software as I used before in the previous video. That's just the camera light coming on, by the way. So as I increase that, we can have a reading. So I mean, ultimately you might want to put the whole thing into one box, but the nice thing about it is you can separate the box from the high voltage to the low voltage. So the high voltage bit's over here, there's actually a split down the middle here, and it's opto-isolated as I mentioned before. Oh, there it is there, I can see the gap in the board, and it's opto-coupled, so none of the nasty high voltages can get back into the computer or to the micro. So it's pretty safe, and I could add another bulb. It's supposed to take up to 500 watts, so this is only a 60 watt light bulb that I'm using. Just turn it up a bit. Yeah. So I could put another one on. It probably should work without any problem. It could possibly work on some kind of fan as well, but it remains to be seen, because you've got to be careful there, because fans have got their own internal controllers as well. So that, you know, may not be quite so straightforward there as just lighting up a bulb. There it is anyway. Thanks for watching. Goodbye.